So the diagram at right represents only half of a shape that has the graph y equals 1 as a line of symmetry. So let's first of all put that on there, y equals 1, right? So, the x values are changing, but no matter what, y's are always 1. So that's this horizontal line that goes along through here. And as I draw this line, x's are increasing as I move, right? X is 8, x is 9, x is 10. But no matter what on that line, the y's always equal 1. So let's go ahead and plot the other 4 points that we have there. I'll put them there in green. There's 1, 2, 3, 4. And basically, that's only the top half of the shape, and we need to reflect this across this line y equals 1. So if I do that reflection, right, one of the points would be, let's see, 2 away, right here. There's the other point. And of course, they would share that point, right? They would share this point, but then it would also have this point right there. So if I was to graph or draw the completed shape, I think it would be looking like this, right? This, and then it would connect these two, and then it would connect those two, and these two, and these two. And again, what's happening is we're taking this thing and we're reflecting across that red line, y equals 1. Now, when I do that, take a look at the coordinates of these points, right? So this point right here is located at 7, 1. The other point is located at 3, -1. They're both -1, I'm sorry. So 7, -1, and 3, -1. And the other thing that we have here is, I just want to glance at what these points were. This was the point 7, 3, and that's the point, what is that, 3, 3. So, cool. That's the entire shape. So the length of a side of a square is 5x plus 2 units. Assuming the entire perimeter of the square is 48 units, complete the following. So first of all, write an equation that represents this information. Well, let's start by just sketching a square, right? And let's go ahead and add the information that we have on there, right? Each one of these sides is 5x plus 2 units long, and I could write that. There's actually 4 of these sides, and they're each 5x plus 2 units long. So one of the ways I could represent the perimeter of this would be 4 times the quantity of 5x plus 2. That's the perimeter. The other thing that I could do, though, is, the perimeter is 48 units also. So that's 2 ways of representing it. So I'll basically set those 2 representations equal to each other, right? One of them is the perimeter is 48 units, and the other one it's 4 of these 5x plus 2s. Now, if I want to find the actual value of x, what I'm probably going to do is divide both sides by 4 first. I should say, if you wanted to, you could distribute the 4 to both the 5x and plus 2 first also, but I think I'm going to go ahead and go with dividing both sides by 4. So if I divide the left-hand side by 4, I'm left with 5x plus 2. And when I divide the right-hand side by 4, let's see, half of 48 is 24, and half of that is 12. So I get that 5x plus 2 is 12. I'll go ahead and subtract 2 from both sides, give me that 5x is the number 10, and therefore x would have to be 2. So x is 2. And then it says, okay, solve for x. And then finally it says, what is the area of the square? Well, if x is 2, that's going to allow me to figure out what the perimeter is. Well, I know the perimeter actually, but if I plug that 2 in there, I get that each side is 12 units long. Right, so it's a 12, 12, 5 times 2 is 10, plus 2 is 12. So all the sides are 2 units long. So the area would be 12 times 12, right? So I guess this is my answer for, let's see, this is the equation. That's the answer for A. That's A. This is the answer for B. And then for C, the area would equal 12 times 12 units, which is 144. And they don't tell me what the units are, so I'll just say units squared. And that's it. Okay, this is question 69, and it's got a lot of parts to it. So one of the first parts, well, it tells me, it says on graph paper, graph the line that goes through the point 0, -2. Let me go and put a point there. So 0, -2. That's great because that's my y-intercept, right? 0, -2. And it has a slope of 4/3. Well, if you look at it, this is my y-intercept because I'm on the y-axis. So I know my y-intercept is -2. And I know that my slope is exactly, what is it, 4/3. So I can write the equation of that line, right? Just the generic slope-intercept form of an equation is y equals your slope times your value of x, and then plus b, your y-intercept. And you can see for this problem, I know that y equals my slope of 4/3 times x, and then that would be a -2. So this is my answer to part A. This is the equation of the line. And the next thing it says, well, it tells me to graph that line, and I actually didn't do that. So let me graph the line. From here, I would go up 4 units, so up 1, 2, 3, 4, and then over 1, 2, 3 units. So this is another point. My next point again, up 1, 2, 3, 4 units, and then over 1, 2, 3 units. So I've got 3 nice points there. Let me grab my ruler and line it up with those 3 points. And then go ahead and just draw the line that goes through them. There we go. So that's the graph of that original line. Part B said it says now translate the graph of the line up 4 units and to the right 3. So if you think about it, if I'm going to translate this up 4 units, that's 1, 2, 3, up 4, and then to the right 1, 2, 3 units, you can see this line ends up going exactly back where it came from, right? So this is the same line. And in fact, that's translational symmetry, right? I take this line, move it up 4/3, and I'm back on the same line. So clearly, if you take a line and you translate it by its slope, you're going to get the same line again. So I just did part B. I did translate it. You can't see any difference though because it's the same. It says write the equation for this resulting line. Oh, okay, I can do that. Let's see. For B, the equation of this new fancy resulting line is y equals 4/3 x minus 2. In other words, it's the exact same line that I started with. Next thing, C, it says now translate the original graph down 5 units. What is the result? All right, so that's a little different, right? I'm just gonna go down straight 1, 2, 3, 4, 5 units, right? 1, 2, 3, 4, 5. So I have a new y-intercept. I guess I'll use green for this line. I have a new y-intercept that's at -7, but it's following the same slope pattern, right? Of up 1, 2, 3, 4, and then over 1, 2, 3. This would be a point up 1, 2, 3, 4, and over 1, 2, 3. And I'll do it again, up 1, 2, 3, 4, and over 1, 2, 3. So there's that slope pattern, up 4/3. This time, though, I was starting at a y-intercept that was down 5 units from -2, so I'm down at -7. Let me draw that line. And I probably should put arrows on these lines because they are infinite. They go forever in both directions. And then it says also, what is the result? Well, I've got this new line that's green here, and it's parallel to the original one. It says write the equation of that line. So for C, the equation of this new line is y equals 4/3 x, and now instead of -2, it's crossing at -7. So there's my new one. And let's see, part D says, how are the 3 lines you graphed related to each other? Well, 2 of them, the first 2 are the same line, but I guess I would say that all 3 of them are clearly parallel to each other. So I'll say the lines are parallel to each other. And this is the symbol for parallel, right? I'll write the word also, parallel to each other. And then let's see, part E is our final part. It says, write the equation of a line that is perpendicular to these lines and passes through the point 12, 7. Okay. So let's see, 12, 7, I'll use this orange color. 12, +7 is right here. So unfortunately, we're not going to see much of this line. It's going to immediately go off the screen. They're not asking me to graph it, fortunately, right? They're just saying what's the equation of a line that's perpendicular to it. So first of all, if lines are perpendicular, their slopes have opposite signs and they are reciprocals. So for part E, the slope of this line that I'm speaking of would be negative 3/4. And I hope that you can see I'm taking the 4/3, right? I made it the opposite, negative, and then I took the reciprocal also. So the slope is negative 3/4, and it's going through the point 12, 7. So if I want to write the equation of that line, probably a couple steps are necessary. Let me just do the work here at E. I would start with the y equals mx plus b, and I'm going to plug in the y value that we know, which is 7. So I would say 7 equals, and then I'm going to plug in the slope, negative 3/4, and then I'm going to multiply that by my x value. My x value is 12, and then I'm going to add b. Now this is allowing me to figure out what my y-intercept is, and I can tell my y-intercept is it's a pretty large number, certainly around 10 or 14 or something like that. So let's solve this for b. Let's see, 12 times 3/4. Let's see, 12/4. There's a giant 1 there. So if I was to simplify that fraction, I've got negative 3/4. And then 12 is a 3 times a 4. So I could write it like this. And I could see I've got a 4/4 is a giant 1. So I'm left with just the number negative 9. So this simplifies to 7 equals negative 9 plus b. Therefore, b is the number 16. So my y-intercept is 16. The question is, what's the equation of that line? I'll write it over here, E. The equation of that line would have to be y equals negative 3/4x, and then plus 16. So yeah, I definitely cannot fit this on the graph. It's going way off this direction. But apparently, if you went that way, you would hit the y-intercept at positive 16. Let's see, write the equation of the line containing the points given in the table below. So as I look at this, I can clearly see the change in y's and the change in x's. So for example, this y value right here increased by plus 3 units, and the corresponding change in x, it went from 2 to 3, so I've got a plus 1 change in x. And it turns out I didn't actually have to use that point. I could have used any of these. If I go from negative 7 to negative 4, that's clearly plus 3 also, right? Negative 7 plus 3 is negative 4. And negative 2 plus 1 is negative 1. So again, I see this plus 3 increase in y and a plus 1 increase in x. So what I do here is I'm going to go ahead and write down what my slope is, right? Remember, slope is the change in the y values divided by the change in the x values. And this is always kind of problematic when students see this, because there's like, in this table, right, the x's, right, are in the top because those are my inputs, and then the y's are along the bottom there. Those are my outputs. So make sure you're real careful and say, oh, my change in my y, that goes in the numerator, and the change in my x's are going down in the denominator here. So the slope of this would be 3/1, or more simply stated, the slope is 3, right? Up 3/1, up 3/1. Now, what I need to do now is I need to figure out what the y-intercept is, and that's not visible on this table, and I could probably figure out what it is, but what I'm going to do instead, I could probably extend the table or do something, but instead what I'm going to do is I am going to, let's see, I'm going to just figure it out by picking one of these points at random, and it doesn't matter which one I pick. Let's see, I'm just going to pick this point right here. So if you look at it, right, I now have a y value and I have a particular x value that I'm going to use. So this is the procedure we keep going through, right? We start with y equals mx plus b. Our y value is 8, right? That's the point I selected. X was 3, y was 8. My slope, we found out, was just the number 3, so that's my slope is 3. And the x value for the point I selected was also 3. So I have 8 equals 3 times 3, and then plus b. So you can see x, y, and m were just plugged into this equation, and the only variable I'm left with is b, which is great because that's what I wanted to find, right? I'm trying to figure out my y-intercept. So in other words, 8 equals 9 plus b, and if I take away 9 from both sides, it turns out that b is going to have to be -1. All right, so now that I know my slope, right, my slope is the number 3, and I know that my y-intercept right here, and I know that my y-intercept is -1, I can write the equation of this line. So my answer is y equals 3x and then -1. So that is exactly the equation of the line that represents this table. On the graph at right, actually it's below, the graph below compares the gas mileage to the weight of numerous vehicles. So every single one of these dots has two pieces of information associated with it. One of them, for example, is the weight of the vehicle, and you can see this one here is below, slightly below 4.5 tons, but definitely bigger than 4¼ tons. And it also has this value right here, which is its miles per gallon, which is somewhere in between 15 and 20 mpg. So it stands to reason, if you look at it, as the weight of the car is increasing, it appears that the miles per gallon decreases. Now, lurking in there is some kind of we call this like a line of best fit, and I don't know exactly where it is, and that wasn't very scientific, but I'm just saying, look, this is kind of a trend line for the data, and what I'm seeing here as one of the variable increases, the weight in tons, the other variable is decreasing, right? So this says describe the association. It's pretty much what we just said. Let's write that down. So as the weight of the vehicle increases, the number of miles that you can travel per 1 gallon of gas decreases. Makes sense, right? You've got a very light little Honda or Toyota Prius or a Honda Fit or something, doesn't weigh a lot. It's going to be able to travel a lot further on miles per gallon for one reason, right? The other is the well-engineered powertrain, maybe hybrid electric or something like that. Anyways, that's question number 71. So our final question of the evening has two functions. One of them is f of x equals 7 plus the absolute value of x. And the other one is x to the third power minus 5, and that's called g of x. So one of them, we cube a number, and then we subtract 5. So it asks us to evaluate several different input values. So let's go ahead and start with the first one here. And the first one says evaluate f at -5, f of -5. So basically, I'm going to take a 7 plus, and then inside where x is, I'm going to place a -5. Well, the absolute value of -5 is 5, so this becomes 7 plus 5, which is the number 12. So f at -5, it produces, if the input's -5, the output is 12 for the function f of x. Now let's look at g. G says this time we're going to take the value of 4 as our input. So look what g does. I always like to show this with parentheses. G takes a value and it cubes it, and then it subtracts 5 from the result. The number that we're cubing is 4, and it turns out 4 times 4 is 16, and 16 times 4 is surprisingly large. It's actually 64. So what I get here is the number 64, and then I have to subtract 5 from that. So when my input is 4, g of x gives me an output of 59, which is 5 less than 64. Let's see, f at 0, that's pretty straightforward, right? That's just 7 plus the absolute value of 0, which is just plain old 7. F at 2, okay, so I've got 7 plus the absolute value of 2. Absolute value of 2 is 2, so this is 7 plus 2, which is the number 9. G of -2, okay, this is why the parentheses are so vital. So, oops, I'm going to put a -2 in these parentheses, and I'm going to cube that and then subtract 5. Now, remember what to the third power means? It means that I have 3 factors of -2. So over here, this is literally -2 times -2 times -2. Well, -2 times -2 is +4. Right, this is 4, and then I'm going to multiply 4 times -2, which gives me a -8. So this becomes -8 and then minus an additional 5, which is -13, right? -8 and minus 5 is -13. And then finally, our last one is what's g of 0? Well, cubing 0 is pretty easy, right? 0 to the third power is 0, and we need to take 5 away from that. So we just get -5 when our input to the function g is 0.